Hello everybody. Today we're going to be looking at a question that caught my eye earlier. It reminds me of a game of telephone, which I hope still makes sense. The way it used to work is that one person would tell a story to another person, and then that person would try to repeat the story to a different person, who then repeats it to someone else. Each time the story changes a bit, and well, now we just screenshot things and forward exact copies to people. So maybe that's not a thing anymore, but, well, I feel like I'm missing something in this question. Anyway, there are a few things that might be obvious to you depending on how nerdy you are. You might have done some work in binary, and some of you might feel that you know the answer already. So let's get into it. Plenty of people have the powers of 2 memorized. It's important for binary and understanding how digital electronics work. You just have to double the previous value and you can quickly produce a table like this one. We can kind of see our solution already. Let's pick the one that's larger than 504, because if we pick one that's any larger than that, we need to subtract more than half of it, which isn't in our table. Then it's a matter of what do we subtract from 512 to get 504? Well, 12 minus 8 is 4, stick a 5 in the hundreds spot, and there you go. Now, if time was an important factor in this, and we just cared about getting as many questions done as quickly as possible, this would be okay. But maybe we need to show some work and present some reasoning behind the answer. So if we recall that 2 to the power of something is just 2 multiplied by 2 multiplied by 2, repeated over and over again, we can change 2 to the power of p minus 2 to the power of q into 2 to the power of p minus q minus 1, all multiplied by 2 to the power of q. If you haven't worked with exponents much, this basically means that instead of multiplying 2 by itself 9 times and then subtracting 2 multiplied by itself 3 times, we're going to multiply 2 by itself 9 minus 3, or 6 times, and then subtract 1, and then we multiply that result by 2 3 more times, though for now we have to continue pretending that we don't know the numbers we're looking for are 9 and 3. So now we need to turn 504 into something that looks like that, starting with seeing how many times we can divide 504 by 2 evenly, which, unsurprisingly, is 3 times. This leaves us with 63. Now we can write this thing, and q equals 3, which means that 63 has to equal the other part. Add 1 to 63 and we get 64. And now we can just repeat what we did earlier and see how many times we can divide 64 by 2, which really clutters up the place. Or resort to that table which we decided earlier was not showing enough work. So let's not look at that mess for too long and move on to 64 being equal to 2 to the power of 6. Therefore, p minus 3 must also equal 6, which means that p equals 9, and we may as well just jot down q equals 3 we found earlier, just so that we have our answer all in one place. Is that it, though? If we bring up a graph of y equals 2 to the power of x, we get this curve. One of the things you'll learn in a linear algebra class is that when you have one equation and 2 unknowns, there's a good chance you'll wind up with a lot of different answers. Nothing about that question says we're looking for those specific 2 points on the curve. It just says we're looking for 2 values that will result in a difference of 504. Larger values of p and q that satisfy this equation will have a smaller difference between them, and smaller values of p and q will have a larger difference between them. If we want to find more answers, we'll need to go more in depth about exponents to understand where all the values for exponents that aren't whole numbers come from, and the exponent's counterpart, the logarithm. So earlier I said that 2 to the power of something was equal to 2 multiplied by itself however many times, and this isn't quite right. For one thing, 2 to the power of 2, which we sometimes call 2 squared, is 2 times 2, which I suppose is better described as 2 multiplied by itself once and not 2 multiplied by itself twice, so maybe a better English word description is 1 multiplied by 2 however many times. I hope everyone is okay if I don't bother writing 1 times whatever. So anyway, earlier we looked at 2 to the power of 3, 6, and 9 when factoring 2 to the power of 3 out so that we had the 2 to the power of p minus q thing. We touched upon one of the characteristics of exponents. We said that p and q were 9 and 3, and we found that 2 to the power of p minus q, or 9 minus 3, was 2 to the power of 6. People kind of decided that this was the important characteristic of exponents, being able to change multiplying and dividing of these repeated multiplications into adding and subtracting things. So 1 multiplied by a number 1/2 of the time doesn't make much sense. But if you multiply 2 to the power of 1/2 by 2 to the power of 1/2, the rules of exponents say that you have to add the exponents. 1/2 plus 1/2 equals 1, and 2 to the power of 1 is 1 multiplied by 2 once, or just plain 2. So now 2 to the power of 1/2 times 2 to the power of 1/2 means that you're looking for something that you can multiply by itself to equal 2, which is something that, while is difficult, it at least makes some sense. Now we can go about trying to find things like 2 to the power of 5.17, which is 1 multiplied by 2 5 times, multiplied by 2 to the power of 0.17, where 2 to the power of 0.17 involves taking whatever you need so that when you multiply 1 by that number 100 times, you get 2 for an answer, and then multiplying that number by itself 17 times. So it's a complete waste of time to attempt to calculate this by hand on paper. It's about 36.00 something something something. It's one of those irrational numbers that can't be expressed in the form a over b. It just goes on forever in a non-repeating sequence because finding something that you can multiply 1 by 100 times to get 2 is just a strange request, so you're going to get a strange answer. On that note, 9 and 3 is probably the only solution that doesn't involve at least one irrational number. I think it is, but I'm not about to try to prove it. So if we go with 5.7 being the smaller number in the answer, or q, we need to find something that's 504 larger, or 540 with whatever numbers left after the decimal. I'm just going to call this number blue for now. So we need 2 to the power of something to equal blue, which I could call P, but let's color code and go with red. So logarithms. If there weren't already enough underexplained ideas in this already, here's one more to add to the list. And I'm going to throw in another color. The 2 is known as the base. Red is the exponent, and if you know the base you're using and the number you want, then a logarithm, or a log, gives you the exponent you need, so that the base to the power of that exponent equals that number. And this is kind of one of those sort of black box things where you're just sort of counting on someone having gone and done the hard work before you, because, well, it's one of those things that's really hard to do, so everyone just sort of lets electronics do that for them. If anyone wants to know, for q equals 5.17, the value of p is a little larger than 9. If you want a value of p closer to 10, then you need a value of q that's around 9. And as long as we're okay with logarithms being in our toolbox, we can write these things as the answer to the original question. And so we've come to the reason this kind of caught my eye and I felt like going through this. Just kind of wanted to say that I've had teachers that would have been thrilled to see someone write something like this for an answer. And I've also had the opposite, teachers who would have given an answer like this a 0. While it does demonstrate an understanding of some advanced math concepts, I wouldn't have been showing that I understood what I was taught in class, which is what the curriculum says that I have to show that I understand. And this was before remote learning was a thing, so I was writing on a sheet of paper in front of the teacher, and it's not like they were going to accuse me of some sort of online wizardry to get someone else to write a test for me when they saw that.